really expands the usages and the usage scenarios for 6 gigahertz Wi-Fi in the US. And the US is a very large and important market, and it's leading in the area of 6 gigahertz, so that's the huge significance to it.
Hello, this is Martha DeGrasse, here again for Wi-Fi Alliance, and this is The Signal, our podcast where we bring you the inside track on Wi-Fi. These are meant to be smart conversations with industry leaders. We want to deliver a new perspective on the growing portfolio of Wi-Fi technologies that we see changing the connectivity landscape. In this episode, we'll be talking about automated frequency coordination, that's AFC, and we are thrilled to welcome Rolf vegt back to the podcast. He is VP of Technical Standards at Qualcomm. Rolf, welcome back to The Signal.
Thank you very much, Martha. Happy to be here.
Yeah, this is going to be a great conversation. Automated frequency coordination, that is foundational to expanding the use of Wi-Fi in the 6 gigahertz band. So let's start with an overview of what it is and how it works.
Okay, a quick overview in a nutshell. So we've got this wonderful amount of spectrum available for new Wi-Fi usages. 1.2 gigahertz became available in the United States. But we're not the sole users of that band as Wi-Fi. There are actually existing operators that use that same frequency band. And that's why initially Wi-Fi could be mostly allowed to use indoors. What AFC does is that now you can also use Wi-Fi outdoors and also at higher powers indoors. But what that means is that we need to make sure that as Wi-Fi, we don't cause trouble for these existing systems that are in the field. And the existing system, you have to think about fixed wireless links, for example, backhaul for cellular communications in rural areas, or in use by utility systems or first responder systems and so on. So these are important systems that we need to make sure that we don't cause interference into the receivers of those systems. So that's why we have this AFC system, which basically there are two components to it. The Wi-Fi access point has to be able to communicate where it is located. It communicates that to a cloud-based system that says, okay, if you're on that location, with all the knowledge that I have about existing systems that are already there, incumbents that are already there, I'm going to calculate and tell you exactly which frequencies you can use at what transmit powers. So that's how it is in a nutshell. There are two components to it. Something is on the Wi-Fi access point and something a cloud-based system that does a lot of the back-end calculations.
And those cloud-based systems are probably deployed in public clouds, private clouds, edge networks. How close do they have to be?
Yeah, so we'll talk in a minute about the fact that now multiple AFC providers are allowed to operate. I'm not familiar with all the models. In the case of Qualcomm, we use AWS, a public cloud provider, and I'm assuming others will use similar kind of models.
Absolutely. Okay, so recently on Friday, February 23rd, the FCC issued a public notice to approve the operation of 7 AFC systems. One is operated by you, one is operated by the Wi-Fi Alliance, and there are 5 other entities operating these. So let's talk a little bit about the significance of this decision and what can happen now.
Well, yeah, the significance is that it really expands the usages and the usage scenarios for 6 gigahertz Wi-Fi in the US. And the US is a very large and important market, and it's leading in the area of 6 gigahertz, so that's the huge significance to it. It establishes and formalizes a spectrum sharing model, which hopefully can be replicated throughout the world. So the fact that the US has made this very important decision will probably have implications down the road for other countries as well that will be looking at the US on how we are deploying it here. What's also significant is that the FCC has embraced a market-driven model for AFC systems deployment. So there were 7 systems approved. When we're looking and we're talking to other countries, sometimes some countries, they want to have only one AFC system, government-run AFC system. And sometimes that's driven based on the nature of the incumbents that need to be protected. If it's public safety, some countries are uncomfortable having all kind of companies use that data, make that data available. So there are different models, but what's significant in the US is that they've really decided, okay, we'll have, out of the 13 that had provisional approvals, 7 are now given the go-ahead to get going, which is quite a lot of providers for a market like this.
Absolutely. And what are some of the use cases for the Wi-Fi access points that are going to use the standard power in 6 gigahertz?
So 3 different types of use cases. So, if you look at the consumer environment, it provides better range for the devices deployed in the home, for your Wi-Fi networks in your home. And so you can think about it as having better range, being able to use Wi-Fi networking, 6 gigahertz Wi-Fi networking in your garden or throughout your home. So by having the higher power available, gives you better range and better throughput at range. So that's a significant benefit in the case of consumers. You can also think about mesh system, those Wi-Fi easy mesh systems, where for backhaul purposes, you can now use, higher power 6 gigahertz links, sometimes 320 megahertz wide. So really powerful backhaul links that you can operate at higher powers and, giving a very robust vibe. From a commercialization perspective, that's actually a very interesting initial use case because those Wi-Fi systems, they are all from the same vendor, and you're not waiting for clients to come along. If you can set up a very robust 6 gigahertz high power connection between the Wi-Fi mesh access point, that's a very powerful initial use case potentially. So that's for the consumer side. And then the other usage scenario is in the outdoor environment. You have to think about broadband access, campus deployments, municipal networks, stadiums. One thing, we were talking about the fact that the US just approved this, FCC just approved this. Actually, we're not the first. Canada was actually first. So they approved AFC operation last year. As Qualcomm, we obtained approval in August of last year to operate as an AFC provider in Canada. And only last week, one of our partners, Cambium, had some press about the fact that they're deploying 6 gigahertz AFC systems. And they use a use case example there in a First Nation location in Western Ontario, where they have a write-up on how they're using a standard power, so AFC-enabled 6 gigahertz Wi-Fi.
That's excellent.
So those are the outdoor cases. And then also for enterprise indoor, we see, significant benefits as well. So warehouses, manufacturing floors where the wireless environment is kind of challenging, hallways in buildings, in hospitality, hotels, people always want to have the best Wi-Fi connection everywhere. So those are the areas that we really see usage for this higher power 6 gigahertz operation.
So lots and lots of use cases. Do you think that enterprises and consumers understand what this technology is, or do you think that there are some misconceptions around this technology?
Yeah, so for consumers, hopefully we don't have to bother consumers with any of this. They just have better Wi-Fi and everything will be under the hood and will be enabled under the hood. That will be the ideal end state. We don't want to be able to have to educate consumers about this. However, when we look in the market and talk to potential OEMs, so because basically parties that will be embracing AFC technologies will be access point vendors or service providers. Those are the 2 types of players that will have to embrace AFC technology and put it in their devices or in their networks. And then the common misconceptions, there are actually 4 that we run into. So one of them is that AFC is only for outdoor usage. So
I actually thought that until recently.
Yes. So which is actually not the case. Yes, it's great for outdoor usage and there's initial use cases. So I mentioned the Canada First Nation example. Last week at the Wi-Fi Alliance meeting in Singapore, we had a very interesting presentation by an entrepreneur from Indonesia that wants to use this for rural connectivity, satellite link to rural villages in Indonesia, and then use standard power 6 gigahertz for a rural municipal network. But I also, in a previous section, we talked about indoor use cases for consumer and enterprises alike. So that's the first misconception, that it's for outdoor only. That's not the case. Higher power indoor is very valuable as well. The other misconception is that all you need is an AFC-based cloud system, and you're good to go. And maybe we can talk some more in a minute about all the different components that you need to actually enable this technology. But yes, an AFC-based cloud system is very important, but there are other critical elements that are needed to make this happen. The third point is, so I spoke about the need that the AP needs to communicate its location to the AFC cloud system. Then people immediately think, okay, well, you need a GPS chip now in your access point because that allows you to get to a location, which is definitely one method. But That's definitely not the only method. There are other methods as well, and we can talk about it in a bit as well, for geolocating your access point. And then the fourth one, and that's more specific to Qualcomm. As Qualcomm, we offer an AFC solution, an entire suite of AFC solution components. And people then think that, you can only use the Qualcomm AFC if you buy Qualcomm chipsets or if you integrate APs with Qualcomm chip, which is not the case. So as Qualcomm, we're quite willing to enable other vendors' access points and service providers that use a mix of access points. So we're quite willing and able to do that. So that's very Qualcomm specific. Maybe, if you allow me, just to talk a little bit more about the geolocation part of it. So the fact that some of the enterprise players, they make the choice to put GPS chips in every access point, which is great, but it's also a significant cost adder. And GPS does not always work inside buildings because you need to have satellite connectivity, right? So there are some drawbacks to it, the cost and technology drawbacks to it. There are other methods, like, for example, using a cell phone that has GPS in it to allow for automatic geolocation of access points. Of course, that has drawbacks because then you have to get the consumer or the end user involved in the geolocation exercise. And we were just talking about the fact that we don't want to burden the consumer with, this complexity, but it is a method that can be used. So using your cell phone that securely communicates to the AP at what location the AP is. And then the third one is something that as Qualcomm we implemented. We call it terrestrial location system, where an access point, a 6 gigahertz access point that powers up, checks with its environment and sees what other access points are around them. They communicate that information to the Qualcomm cloud, and based on, we've got a database of billions of geolocated access points, then our cloud can tell you where that access point is located. So it's a software-only geolocation solution that can be made available. So you don't need to, you don't need to futz around with phones, and you don't need to implement GPS chips in your access points. So there's just some things that we run into, just to give some context on that. Yeah.
Okay, so obviously when you said before that all you need is a cloud-based system and something on the device, there's a lot going on the device. There's a lot more going on. So what all is needed to enable a complete standard power solution?
Yeah, so we mentioned the access point. So let's talk first about access point. So
okay.
The access point needs to be 6 gigahertz capable. It needs to be standard power capable. So that sometimes means implications for the power amplifiers that you put in an access point. The access point needs to have some software on it that allows it to talk to an AFC that is sort of a generic software, because there is a standards-based API that defined by the industry that you need to implement. But you also need to implement software that allows you to set up a secure connection between your access point and your AFC provider of choice. There's a requirement to make that secure, so you need to have some software in that access point that allows that secure connection in that access point or proxy for access point. So that's on the access point side. Then you have the AFC system, obviously, that the cloud-based AFC system that you need to have in place to make this all work. And then the third portion is the geolocation piece. So you need to be able to figure out what location you're at and communicate that. And we mentioned the method, the GPS method, the phone methods, the terrestrial location method. There's another part to it, is that in addition to the horizontal locationing, it's going to be important to know at what height you're located. Because if you're higher up in a building, for example, there's a higher likelihood that you cause interference, because typically the receivers of those existing systems are also implemented at a higher altitude. So the height determination is an important part as well. You can use GPS chipsets for that. GPS chipsets, have a way to also determine height, but there are also other methods. And actually, as Qualcomm, we have come up with two different methods. One of them is barometric pressure height determination. So in that case, you put a barometric pressure sensor in an access point. Then you measure, how much pressure am I getting? So high up in the mountains, the pressure is lower than at sea level. And with that, you could calculate what height you are. However, barometric pressure is, as we all know, is weather dependent. So you have low pressure, high pressure systems and so on. So what we do in the case of the Qualcomm situation with barometric pressure is that an AP communicates its barometric pressure that it's reading. then we have information in our cloud where we know what the weather situation, what the barometric pressure situation is in your particular location at that point in time. And that's how we use to weather correct the exact reading on the height. So that's another method for height determination. And then the third one is what we've also implemented is a building database-based height determination. Because most of the US, most of residential areas, people are living in maximum 2-story homes. So if you know where you are, if you have the location, we can look at a database of, for that particular area, what are the building structures? Is it a residential area of maximum 2-story homes? Well, then we pick that as the height. If it is you're in a downtown area and you're geolocated in a high-rise building or very close to a high-rise building, then we have to do something different and then have to assume that you're high up in that building, unless you use other techniques like barometric pressures and so on. But so that's on the geolocation side, some of the things you need to run a full system like that.
Okay, excellent. So I think that you've gone through probably most of the technical elements. Now, on the business elements, do service providers and device manufacturers likely consume this as a subscription, or how will they get this AFC?
There are a few things to it. Most likely, and that's the commercial terms. It's very early in this market.
Okay.
It's that it's a market-based approach. So 7 vendors, each of them may have different approaches to the market, so we don't know.
Okay.
It could be a subscription model. One point of note, though, is, yes, there are 7 providers, but it cannot be like, okay, I just bought my access point today, and now let me figure out which one of the 7 I'm going to pick. Because there is a requirement of an AFC systems vendor to have code implemented in that access point. And that is not just some, consumer code that you download from the web and put it on your access point. There's actually actual integration effort needed to implement something like that. So there is some kind of a upfront investment needed. So even some AP vendors are saying, I want to offer choice, I at least want to have 2 choices or redundancy. That does mean that particular AP vendor needs to have a relationship with at least 2 of these AFC vendors that need to put their code in that access point, because you need to be able to set up a secure connection between the access point and the cloud system. And to enable that security, you need some software on that AP. And putting software on an AP, there are only very few parties that actually do that. It's the OEM itself or the ODM in Taiwan that actually works for that OEM, or the chipset vendor, but that's a smaller community.
And it sounds like the AP vendor has to go through quite a bit of testing, probably with each of the AFC vendors. It sounds like there's a lot that has to be tested and trialed before they can sell that AP, claiming that AFC is going to work.
Yeah, actually talking about testing, that's important for Wi-Fi Alliance, right? What we're doing in testing. So if you look at the components of testing, so the AFC systems themselves, have to be tested. And that's what the whole announcement from the FCC was all about. So industry had developed a test plan, was Wi-Fi Alliance and Win Forum together developed a test plan. That test plan was used by certified test houses, qualified test houses, to look at the AFC system and then approve it. And then the FCC took that test report and validated it and then make their decision known. So in the case of Qualcomm, we used DECRA. They looked at our implementation, our test plan, this industry test plan. They conducted the testing, and that was all submitted to the FCC, and that's how the AFC cloud-based system got approved. In the case of a standard power access point, so what's needed there, of course you need your Wi-Fi 6E or Wi-Fi 7 testing. But then in addition, you need to test for the proper operation of the AFC interface. So the AFC interface has been defined by the Wi-Fi Alliance. The Wi-Fi Alliance has also defined a test plan and a test harness. But then there is a qualified test lab that actually runs all that, and that then proves that, okay, if an AP gets a certain command from an AFC system saying, i.e., you can use these frequencies or you cannot use these frequencies, then the lab tests for whether you actually do what you're supposed to do. So those are the major test components.
That's a lot. Is there anything else we need to know about testing?
Yeah, maybe there's one other piece to the overall solution that I talked about, so which is the geolocation piece. And so that needs to have some testing and approval as well. And the way that's working out is that in the case of the US, you need to get approval by the FCC. And they have a very specific process for that. They call it the PIA, the Persistent Inquiry Authorization. And so only 2 or 3 weeks ago, in the case of Qualcomm, we got this PIA approval for the terrestrial geolocation method, this massive AP geolocated database locationing approach. Also for this barometric pressure height determination method and the building height determination method. All of those 3 were approved by the FCC.
Wow. Okay. All right. All right. You talked a little earlier about how Canada was ahead of the U.S. for this. I think every country gets to decide, right, how the 6 gigahertz band is going to be used. Will AFC be used in other countries going forward, or are there any other countries that have already started using it?
I'm not aware of any other countries starting using it. There's definitely a lot of interest from multiple countries that are studying using this approach. I'm sure, a lot of regulators will be watching what's happening in the US and Canada with this. But, in countries like Japan, they're now looking at it. Taiwan is interested, Brazil, efforts on this area. There's a whole standards effort in Europe and CEPT where they start to look at potentially applying some of these technologies. But as of yet, it's Canada and the U.S. are the first ones out of the chute.
Okay, great. Well, maybe we'll have to have you back in another 6 months and see what the latest is.
Yes.
All right, Rolf de Vegt, VP Technical Standards at Qualcomm. Thank you so much for being here on The Signal.
Thank you.
And that is our show. Don't forget to check the show notes for more resources, and be sure to follow The Signal on Apple Podcasts, Spotify, Amazon Podcasts, or at Wi-Fi Alliance. That's y-fi.org. I'm Martha DeGrasse. Thank you so much for listening. Join us next time on The Signal.